Morning, everyone. How's it going? Last day of new chem today. Woohoo! You're almost done. You've almost made it. Congrats. Not an easy class to take remotely. Most of you doing a great job. Thank you. All right. Just a reminder, test is Friday, 9:30, 11 a.m. only. Only makeup is a makeup paper. It would be due Sunday night because I have to have grades in by like noon on Monday. So it's a quick turnaround or whatever. So I don't know how that would even work. Today we got one last thing to talk about, which is called an electrolytic cell. We talked about voltaic cells last class. We'll talk about the similarities and differences. We talked about the similarities last class, but we'll review those again. Tonight, it's practice for your test, study for your test, do your review problems. I'll put the answers for the Regents kids up today. I should be able to. Don't forget, you got your quick little redox project due tomorrow at midnight. When you're doing that, I've had some questions. You know, the reactions, pick a reaction, you can find the reaction. All right? I'm not expecting you to write the reaction on your own. You should be able to find what the reaction is. Then you just have to pull out the half reactions. You know, the one reaction that's oxidized, the one reaction that's reduced. Okay? All right, not intended to be super hard or super long. It's just, you know, getting you some practice with some stuff outside of the box, so to speak. All right, here we go. Okay, so I'm going to go right into answering this. So it says, which reaction can occur at the anode in a voltaic cell? First of all, voltaic cell is what we talked about last class, also known as a battery. The anode, if you remember, the anode is the one that's oxidized, or is where oxidation occurs. So another way you can do this is figure out which one of these is an oxidation reaction. All right, chemistry, when you're talking about multiple choice questions, a lot of the times if you can isolate one answer, it's probably correct. Which one of these ones is not like the other, that old Sesame Street song. In this case, choice C is the actual answer because this is showing oxidation. This is showing a loss of electrons or electrons on the right side. All right. So therefore it's oxidized. You do not know what the other metals are in this situation, so the only way you could answer this question is being able to identify the oxidation half reaction in there. Okay? All right, here we go. Quick review of last class. It says which electrode below is the anode and draw in the flow of electrons on the wire. So first things first, you have a voltaic cell. You got two containers connected by a salt bridge. Remember, a salt bridge, one purpose, permit the flow of ions. That's it. Ions, not electrons. Electrons and ions are not the same thing. All right, another way to say it is it maintains neutrality, all right, or keeps it balanced. All right, you could figure out which one's the anode a couple of ways here. They give you the overall net ionic equation, which we talked about, showing you just the particles that are involved. Or you can look at the two metals and look on your table J. So I'm in a different spot taping this morning. People were up early in my house today, so I didn't want to have the background noise of them. I don't have a reference table right here, but if you look up nickel and if you look up silver, nickel would be on top of silver or above silver. Silver is less reactive than nickel, so the electrons are going to flow from nickel to silver. You could also look in the reaction down here and see that nickel goes from a 0 to a +2. So that's going up an oxidation number, which means it's losing electrons. So therefore, it's got to be oxidized. And you can see silver is going from 0 to a +2, which means it's gaining electrons, which is going down. So you can figure out either way. So in any way, shape, or form, nickel is the anode. All right, therefore, silver has got to be the cathode. Now, to draw in the flow of electrons, because nickel is more reactive, the electrons are going to draw in like this. All right, in this case, they're going to flow from left to right. All right, they're going to go from nickel to silver. All right, so silver is going to gain reaction. So if you look down here at the reaction, you can use this to write the half reaction. If you want to use this, so you go 2, I'm going to write really bad, sorry, 2Ag plus arrow, oh my goodness, 2Ag0. So now all you have to do is write in which side has the electrons. All right, in this case, the plus is higher than a 0. All right, so this side is going to get the electrons. Man, this writing is awful. I apologize. I'm using a different surface. All right, and then to make this mathematically correct, because there's two of them, you have to put 2 electrons. So it's Ag, 2Ag plus 2 electrons equals 2Ag 0. All right, you can do the same thing over here with the nickel. Yeah, Ni 0. All right, let's go arrow. Sorry. And then Ni, in this case, plus 2. And to make this balance, you got to add electrons to the high side, so you put electrons over here. And then you have to make sure you have the right number of electrons because you're going 0 to plus 2. This has to gain 2 electrons. So those are the 2 half reactions, which is one of the things I think that kids have issues with. All right, you don't need, all the information you need is right here. It does not matter what what concentration of solutions are. Just as long as you have ions in solution, you're good to go. All right. Okay, so that's our wrap up of voltaic cells. Remember, voltaic cells are spontaneous. Spontaneous means they happen without external energy. All right, so it is spontaneous. I'm going to put a clip up on YouTube today. If anybody's ever watched Breaking Bad, there's a scenario where I think the RV is dead and they need to jumpstart the battery, and he has lots of chemicals and such for what he's doing. So they build a battery and they go through the battery. It's kind of funny. I will put that up for you to watch. It's about 2 minutes, so I'm not going to film it right here. All right, so here we go. Electrochemical cells. This is the second one. It's called an electrolytic cell. All right, which in this case, it's taking electricity to make a chemical reaction occur, or to force a chemical reaction to occur. So this is a non-spontaneous reaction. This is a reaction that would not happen without the source of energy. All right, and this is what in class we would use this process we would plate copper onto a key and turn a key into look like a penny, so to speak, the color of a penny at least. They do this to isolate and purify metals, or to plate metals, like I said. All right, so these are not spontaneous. They're forced by the addition of electricity. You could do this stuff at home, but it's not super hard, but it's not super easy either. Big difference is electrolytic cells occur within one container, not 2 separate cells. So if you look at the voltaic cell here, this has got 2 separate cells. All right, cell 1, cell 2, or cell A and B, it doesn't really matter. All right, in a battery, they're like inside of each other. It's not like they have to be 2 separate containers, so to speak. They just have to be separated somehow, some way. All right, so an electrolytic cell, it occurs in one container, and these are used to plate metals onto another. You can use it to purify, like to get the group 1 and group 2 elements, like pure lithium, pure magnesium, pure sodium. They need this process. And you can also use this to separate or split compounds, like to split water into hydrogen and oxygen. That one type of vehicle that they're trying to develop where you put water in as your quote unquote gasoline. They split it into hydrogen oxygen gas and then recombine it to form water. All right, this is part of it. The electrolytic cell would be part of that process, some type of thing in there to do that. If you watch The Martian, he made water this way, and when he needed to make the water with the metal plate and such, which ultimately caused the explosion. But that's a story for another day. All right, so here we go. General thing. Here's our one container. I drew it pretty big. All right, and you need some electrical source. I drew it as a battery because that is a source of electricity. All right, drew it as a battery. In this case, we're gonna plate some metal onto, I think it's a spoon, if I remember. It's a spoon or a fork. I think it's a spoon because a spoon's easier to draw than a fork. All right, so we got some hunk of metal here. So in this case, the metal we're choosing is tin. All right, we're gonna plate the tin onto a spoon. All right, I thought it was a spoon. Spoons are way easier to draw or to make than forks. Okay, in this case, the spoon's made of iron. Does not matter what the spoon is made out of. That iron that the spoon's made out of is not involved in the redox at all. All right, it's just a site of that happening. All right, so what we're going to see is that on one side we're going to have tin being oxidized, and on the other side we're going to have tin being reduced. The iron is not involved in anything in here. It's just a source of it happening. All right, so now what we have to do is we have to connect these to the battery. All right, the metal that you are plating on to something else, like if you were gold plating or copper plating, in this case we're tin plating, all right, that's going to get connected to the positive terminal. All right, the thing that you are going to put the metal onto is going to be connected to the negative terminal. So here, the tin, your source material, is connected to the positive terminal. The item that's being plated is connected to your negative terminal. And I would tell you in class to make sure you have good notes, because I wouldn't give you notes for the lab, and you wouldn't want to take the metal off of your key and put it onto the hunk of tin, or in our case, onto the copper penny. All right. The other thing you need is you need a solution. All right, in our solution, what's important that the solution has is tin ions. All right, it's got to have some compound that would form tin ions. All right, if it wouldn't form tin ions, like if it was insoluble, according to table, testing my memory, table I, maybe, the solubility chart, I don't remember what the letter is. All right, but you need tin ions. The chloride ions in this case are just spectators, they're not doing anything. So we got our container filled with solution. All right, with tin ions in it. So those tin ions are going to be very important. I'm just going to get a different color. Let me see what this looks like in here. That we can see. Okay. All right. So here. Now, the big difference, one of the other big differences between electrolytic and voltaic cells is the cathode in an electrolytic cell is negative. In a voltaic cell, the cathode is positive. All right. And this doesn't change. There's no logical way to figure this out. I've tried. It's one of those things you just have to memorize. In a voltaic cell, the cathode's positive. In an electrolytic cell, the cathode is negative. All right, so it's going to become negative. All right, as a result of it becoming negative, so it's going to pick up electrons over here. Let's just say it picks up 2 electrons. I think that shows up okay for you. I'm going to go to a darker color. This should be better. So it picks up 2 electrons here. All right. And as a result, what's going to happen is it's going to, because electrons can't go off into solution, it's going to attract the positive tin ion from solution. All right. And what's going to actually be happening here is at the cathode, remember the red cat gets fat and the anorexic ox. So at the cathode, it's going to become oxidized, or cathode is reduced. Red cat gets fat. So it's going to reduce this tin ion into a tin atom. All right. And as a result, it's going to plate tin onto the spoon. All right. To save my writing today, all right, we're going to take the tin ion plus the 2 electrons on the spoon, and they're going to make a tin atom. So for every 2 electrons that come through here, all right, you're going to make a tin atom on here. And if you continually drive the electrons to that spoon, you're going to make more and more tin atoms. And that's how the spoon gets plated. All right, the longer you let it go, the thicker the material is plated. All right, so some people like to have it real thin. Some people like to have it thicker, so in case you scrape it or something, that it lasts. All right, but here at the cathode, the red cat gets fat, just like it's in the voltaic cell, things are reduced. All right, so we're going to take the 2 electrons coming into the spoon plus the tin ions from solution are going to reduce into a tin atom and be placed on the spoon. Okay, over here, because the battery is forcing electrons in this direction, all right, because the electrons are going out the negative terminal, it's got to replace its electrons with electrons from the tin. So there's actually going to be electrons that are coming from the tin. Every time 2 electrons get put onto the spoon, 2 electrons are going to be pulled off of the tin. All right, as a result, the tin is losing electrons, which means it's oxidized. All right, and if it's losing electrons, it's going to become positively charged. All right, as a result, it's going to lose a positive ion in solution. So here, up here, it's got 2 electrons that are going to get pulled off of it. All right, and then as a result, there's going to be a tin, the tin atom is going to turn into a tin plus 2 ion. So for lack of drawing more. So basically every time a tin ion is pulled out of solution over here, as long as there's still a source of tin here, a tin ion will be put back into solution over here. So the overall number of tin ions in solution doesn't change. And that's critical. And as long as you have some solid tin left, if you run out of all your tin, then that doesn't take place. All right. So our reaction here is we take our tin atom. It's going to lose electrons. It's going to lose 2 electrons because it's going to turn into a +2, and then it's going to form a tin +2 ion that's going to be kicked off into solution. So over the course of time, what's happening to the cathode? The cathode's getting bigger. Remember, red cat gets fat. All right, and over the course of time, the anode's getting smaller, the anorexic ox. All right. Remember, electrons always flow from anode to cathode. That's the same in both voltaic and electrolytic cells. So electrons in a battery, or if it's a circuit that you plug into the wall, it doesn't matter. Same thing, functions the same way. Electrons are going to flow from positive to negative, and that's how you determine in an electrolytic cell which one's the anode and which one's the cathode. The cathode's going to be the negative side. The anode's going to be the positive side. So that's, in a nutshell, electrolytic cells. I would, for the test on Friday, keep your notes handy. Just like this, and you just have everything to refer to. And that's all, folks. All right, you guys done. All right, you survived, you finished, you're done with chemistry. All right, you guys did a fantastic job finishing up the year doing it this way. Not the easiest way, but I think a lot of you were able to manage very well. All right, and I appreciate that. All right, hopefully we'll see you back in the fall, and have a great summer after the test on Friday. All right. Thank you. Talk to you later. Bye.